So, good morning, all of you. I am Manish Kumar from CSC department, Ajay Kumar Garg Engineering College. So, today my second complex topic from the unit 2 in machine learning, that is learning in a neural network using back propagation rule. Okay, students. So, we all know what is a neural network. There are several different approaches that we use in machine learning. As we all know that machine learning is a multidisciplinary subject where we get flavors of all the subjects here. So there are several techniques to train a machine. So for that we will devise different algorithms. So today an important topic that I am going to discuss. Let us start. So we all know what is learning. Learning, we have learned about कि learning is a concept. What is a concept? It is a Boolean valued concept that we have defined in previous lectures. So it is defined as a concept Cx, whose value is equal to 1 or 0, that is true or false. So neural network is a technique through which we are going to train a network. We are going to implement an algorithm, several approaches which help us to train a network, a machine. Okay, let us start. So in my introduction, I am going to brief you about what is neural network, how this network, we get this network. Okay, what are different properties, how we represent this neural network, what are the different models, that is Perceptron model we will study. I will give a brief overview of that, what training rule we will implement, and lastly discuss about how we are going to implement the back propagation algorithm. Okay, so let us start. So we know that artificial neural network provide a practical method for learning real valued, keep in mind this, real valued, discrete valued and vector valued target function. So as we know that when we teach a machine, what is our approach? Firstly, we will decide what is the training example, number one, and secondly, we will find out the target function. Then we will find a way how to represent that target function. So this artificial intelligence is the way, is a science which help us to achieve this aim. Okay, so this target function is important here, because what is a target function? We get some example, training example, and we will find a target function. And with the help of this artificial neural network, we will find a way how we are going to train the network. Okay, so firstly we should know what is this artificial neural network. So this neural network is inspired from the human brain. Okay, inspired from the human brain. So we get a motivation from the biology. The study of artificial neural has been inspired by the observation that biological learning system are built of very complex webs of interconnected neurons. So we all know that in our brain we are millions and trillions of neurons. So I just want to give an example. For example, I have just pick a hot cup of tea. So I will sense it contains a hot tea. How I sense? Because some electrical signals from my hand coming to my brain. So those neurons were analyzing that I just hold a hot cup of tea, right? So this is the processing of neurons. So what neurons will do? The neurons will contain the experience. Okay, students, experience. So from these neurons, the neurons of human brain, we are inspired from these neurons and we make a artificial neural network. Okay. So as we know that this human information processing system, it consists of brain neuron, which is the basic building block cell that communicates information to and from various parts of a body. So I can say that this is a neuron. By inspiring from the neuron, we will devise a simplest model of neuron. Okay, so we will consider it as a threshold unit, and we will give a name of processing element, P's. We will use several P's, processing elements. Okay, so this is a diagram of a brain, you all know that. And this brain, human brain, it consists of millions and trillions of neurons. See, millions and trillions of neurons. Always these are the processing elements. These are the processing elements, neurons. Okay, na? And each neuron is connected with millions and trillions of neurons. See, This is the zoom I have done. This is the structure, neural. So you all have studied in the biology. Yes, right? See, this is the structure of neuron. So from this biological neuron, this artificial neural network is built. Okay, see. So I have defined this neural. This is a simple model of a neuron which consists of dendrite, a nucleus, a cell body, axon, okay, and synapses will be there. Synapses, each neuron will connect with another neuron with the help of these synapses. Okay, so this is a diagram. So inspiring from this diagram, artificial neural network has been made. Okay, students. So there are several facts you should all know. So there are, as I said, there are millions and trillions of neurons there. So number of neurons 10 to the power 11, connection per neuron. Each neuron is connected with several neurons. Okay. Switching time means as I have see something, so the switching time means the response time is very fast. Okay. We can recognize a particular scene. The time is around 0.1 second. We just recognize कि I am seeing this PPT. So the response time is very fast. Okay. So these are some facts. So we can compare it like in our human brain, it is just a highly parallel computation that is based on distributed representation. Okay. So what are the properties of neural network? There are many neurons which are interconnected with each other, like the threshold switching unit, many weighted interconnection among units. They are performing like a highly parallel distributed computing. Okay. And we will just emphasize on the tuning. Tuning means that whenever something happens to us, all those events were stored in our brain, in those neurons. Similarly, we will just tune our network with the help of some weights. Okay, we will see how we will assign some weights. So input is a high dimensional discrete or real valued input. Okay, for example, what is the input here? Sensor input. Okay, the camera will capture and that input will go on to a neural network and we will train our network and machine will learn from that training. Okay, so now next we must know when to consider neural network. Okay, so for considering neural network we have much data. When we have lot of data, we use neural network and also accuracy matters. We want accurate output. So for that we will use neural network, most of us. Okay. So these are several examples. For example, where we can use neural network: speech recognition for classifying the images, some doing the financial prediction in banking sector. So there is a lot of practical implementations where we can use this neural network for training a machine. Okay. So here I am just briefing out कि this is a model, biological model, and inspiring from this biological model we make a model that we called it, this is an artificial neural network. So we are getting an input, these are the inputs, several inputs, we have n number of inputs, all those inputs are summed, we will do summation and we will get output. So from the biological neuron, artificial neural network is made. Okay. So this is how we will work. We will give input, this is the input function, summation will be done, and after summation activation function is used here. There are several activation functions like signum function, sigmoidal function, sine function, step function, which will control the input, and output is generated and we will get output link, and this output can be an input to some other network. Okay. This is the brief illustration. So we have given several instances, input values x1 to xn, okay, and each edge will have some weight w1, w2 up to wm. Okay. What we will do, we will just give a smaller value to this weight, and this weight and this input will be summed and we will get this summation function. After the summation function we will use some activation function that I have just briefed. For example, step function, signum function, sigmoidal function. These are the some common function that we used to control that input, the activation function, and after that we will get some output. So we can say that this is a simple model of artificial neural network. Okay, these are the activation function that we will preferably use. Number one is step function, which will generate a linear threshold unit. Sine function, the behavior of this sine function is like this. Sigmoid function, which will behave like this. Okay, so these are some functions that are already predefined, and we will use this function to control the input and provide the output. Okay, how we will use this function? Let us see. So firstly, you just see, this is an example that I just want to show you that this is a example of neural network implementation that has been done in late in 1993. So this is a driverless driving has been done. Here the camera is used, and this camera is sensing the input images, and we are driving this car and this on the highway. Okay, so this autonomous driverless car implementation is done with the help of neural network. See, a neural network is this. What here we are using 30 by 32 sensor input retina. That camera is capturing that images, and in our neural network we have several units: input unit, hidden unit, and output unit. Okay, and this can be viewed in a computer. This black and white dots, you can see this. This is my hidden unit. This is the hidden unit. How it is shown. This is a hidden unit. This is the implementation how we can see in a machine, in a computer. Okay, so this is an implementation that is, this is a prototype model of artificial neural network learning, which is provided by Pomerleau in 1993, and the name of this system is called as Alvin. Okay, na? So we are use this artificial neural network to steer an autonomous vehicle driving at normal speed on public highway. This is this is the implementation of the artificial neural network. So here in this network, in this example, the input to a neural network is, this is the 30 by 32 grid of pixel which is used, that the camera is capturing the images. Okay, na? And we have 4 units, hidden units, and that input unit is providing a input to a hidden unit, and hidden unit output is going to the output unit. Okay, so now I want to brief you about this artificial neural network can be categorized into different types. Okay, so artificial neural network architecture consists of several layers: input layer, hidden layer, and output layer. Okay, there are the 3 layers that we divide. Several architectures were there. The input layer is responsible for receiving the information. Okay, all the signals we get at input unit. Okay, hidden unit will do some calculations. Output unit will provide the output. Okay, this layer is also composed of neurons, and in this artificial neural network, these neurons were called as processing elements that I have briefed you earlier. Processing elements. Okay, so how we divide this network? These are further classified into 4 types. Number 1 is single layer feed forward network. In this single layer, we have input layer, one input layer, okay, and an output layer. In this single layer, we have an input layer and an output layer. This is called a single layer feed forward network. Okay, in multi-layer, we have a input layer, a hidden layer, okay, hidden layer, and output layer, which consists of multi-layer feed forward network. Okay, third is recurrent or feedback network. In this network, in this feedback network, a network is giving input to the hidden layers also, a type of feedback. Okay, this is the recurrent network, and where the processing elements were arranged in mesh type, in mesh, like a mesh processing elements. This is a mesh network. So there are several architecture. Now it will depend on our calculations, on our computations, which network we have to use. Okay, so for example, how we will come to know that which network we have to use? This is the main problem. This is the main problem that we have to find out. when we have to use what type of network. Okay, so for single layer, whenever our data set can be classified between positive and negative examples, there we have to use a single layer feed forward network. Okay, for example, when we are implementing a truth table of and or gate, okay, we know that AND will generate whenever we will get true input, we will get output of 1, otherwise the output is 0. Okay, it means we can classify our input set into two categories, either 1 or 0. For example, we have a set of positive examples, we have a set of negative examples. We can easily distribute, linearly separate those examples, positive examples at another side and negative example is at this side. So we can easily differentiate between this. When the problem is divided, linearly separated in a linear time, positive and negative, there we will use this type of problems can be solved using single layer feed forward network. Okay, whenever, for example, in case of XOR, what is the truth table of XOR? XOR says that whenever we get opposite input, we will get output as 1. Okay, means the problems which cannot be separated in linear time, those problems were solved using multi-layer feed forward network. Okay, okay. So let me show you the illustration. So by inspiring from the artificial neural network, a model has been developed that is called as Perceptron model. Okay, this Perceptron is a single layer neural network. Okay, we will give a input. What type of input? Some real valued input should be given. Okay, and how we are going to calculate? We are do calculation using a linear combination. Okay, this input of linear combination, this linear combination is done like this. Okay, W0 plus WX x1 plus and so on, WX. What is W? W is the weight, and x1, x2, these are the input, real valued input. Okay, students, and this W0 is some threshold that we will give, that the weighted combination of the input W1 x1 Wn xn. So we will input this W0 as a threshold. Okay, and after that a function has been defined, this activation function, signum function, that will provide 1 if y is greater than 0, and it will provide -1 otherwise. Okay, so now what we have to do, we have to just come to know that how we are going to calculate this these values. Okay, so learning a perceptron involves choosing a value for the weight. Now how this weight is going to be calculated? We just keep a smaller value for the weight. Okay, W0 to Wn. Okay, therefore this is space H of candidate hypothesis considered. What is this hypothesis space? Hypothesis space can be defined as all the combinations of the input, that is space that will include all the legal moves, that is defined as a hypothesis H. Okay, how it is defined? This hypothesis H will consist weight, that weight will belongs to some real valued input, r to the power n plus n. This is a function of hypothesis that will contain all the legal moves. Okay, so why do we need weight and bias? In this, I have just shown in a diagram. We are defining it with a symbol W, and bias is called as B. So why in a neural network we need weight and bias? Weight shows the strength of a particular node. Okay, and bias value allows us to shift the activation function curve up or down. So we need a bias function also. Okay, to just handle that artificial neural network. See, this is the diagrammatic representation. So we are giving, this is my constant input x0. Okay, we are giving the instances, the input x1 to xn. Okay, each edge will be have some weight, W0, W1, Wn, and we will do the summation. Summation will be done like this. Summation is equal to x0 W0 plus x1 W1 and so on. This is the linear combination. So after summing, we use activation function. See, this is a step function. In place of this step function, we can use a signum function, we can use a sine function, we can use a sigmoidal function, just to control the curve, to do up and down, and we will get the output. Okay, this is how a perceptron model looks like. So in this perceptron model, we have just this input layer, number one, and an output. Output is generated. So this is a single layer feed forward network. So this single layer feed forward network is used for problems that can be separable in a linear time. Okay, for those we will use this single layer perceptron model. Okay, see how we are going to do calculations here. Similarly, again I have used summation. This I have told you before also. Okay, and what type of function? In a vector form, I am representing this output function like it will generate 1 or minus 1. It will generate 1 if weight will get multiplied with x. This is the vector representation. Okay, we can show discrete representation also, as well as vector notation can also be shown. So this is the vector representation. Okay, this is the discrete representation. Okay, students. So this is how we can represent a single layer perceptron model. Okay. So this is an example, a live example where we can use a network to implement. For example, we are given an input, several pixel inputs will be given. Input layer, we have some weight. These are the weight values. Okay. Input multiplied by weight. S will be calculated like this. See. Okay. First input multiplied by 0.25 weight. Second multiplied by 0.25, third multiplied by 0.25, and so on. Okay. So we will get plus 1 or minus 1. Plus 1 means bright, minus 1 means dark. Okay. So one should know this representational power of perceptron. As I have just discussed before, that we have a data set, okay, which can be separable in linear time. See, here it consists a positive example. Positive examples are here. Here it is a negative example. So the problems which can be easily separable in linear time, linearly separable, can be solved using single layer perceptron model. Okay, and the problems which cannot be separable using linearly can be solved using multi-layer perceptron model. So for that we just represent it using a decision surface representation. So this diagram is a decision surface representation. In this first diagram, decision surface distributing linearly separating the points. Here in this we can't separate linearly because this is positive example lying above, lying below also. So this cannot be separate linearly, no linear separability. Okay, this is an example of linear separable, this is an example of non-linear. So we should come to know that the points which can be the training examples which can be linearly separable can be implemented using single layer feed forward network. Okay, and the training examples which cannot be separate linearly are implemented using multi-layer feed forward network. Okay, so this is how we come to know which network I have to use. So for example, for illustration purposes, this is a single layer implementation. I have just explained you before कि this is the truth table of AND function. We have two inputs 0 0 0, 0 1 1, 1 0 1 1 1. Okay, so how we calculate the values? A and B input is given. This is the weight value that we have assigned. For example, 0.6 I have assigned. So how it is calculated? See, it is calculated like this कि A 0, ठीक है, B is 0, ठीक है. So I have multiplied the weight. As we know that we will do the summation. So we will get this 0. For second input, we will get 0.6. This is A, this is B. We will get 0.6. For third input, this is A, this is B. We will get 0.6. This is not greater than the threshold value. What is the threshold value? 1. And this is the fourth input, A, B is equal to 1. This will exceed the threshold 1.2. So the output is 1. So this is the illustration of the single layer perceptron model. So similarly, we can also implement OR function also. Okay? It means that this data set can be linearly separable. So we can solve it using a single layer perceptron model. In case if we are using XOR, using the truth table of XOR, this cannot be separated. 0 0 0 1 0 1 0 1 1 1 1 0. This is the truth table of XOR, right? So we can't separate these inputs A and B linearly. Okay? So we need to implement using multi-layer feed forward network for this XOR implementation. Okay? If we are using XOR function, we will use this. Okay, students. So what training rule we are using here? As we know that the learning problem is to determine why we are using the learning problem. It is used to determine a weight vector that causes the perceptron to produce the correct either 1 or -1 output. Okay, for each training example. So when I will call it to learn a acceptable weight vector, so we will begin with a random weight, and this weight will be iteratively applied to the perceptron model. है ना? And we will modify the perceptron weight whenever it misqualifies an example. We will check whenever it will misqualify the example. We will repeat this process iteratively, okay, and we will check whether that example is correct or not. Okay. Thirdly, weights are modified at each step according to the perceptron training rule. Okay. So this is the training rule. The weight is modified. We will modify the weight. Okay. So how we will modify the weight? Using this eta. Eta is called as learning rate. This is called learning rate. So we will use several rules to find out this learning rate. Okay. So there is one drawback that I have written here. The perceptron rule finds a successful weight vector when the training examples are linearly separable. Okay. When the training example is not linearly separable, then it will fail to converge it. Okay. Now what we have to do to implement this non-linearly separable. For this non-linearly separable, we have to use a multi-layer feedback network that is called as back propagation network. Okay, students. So for training this, a training set having a non-linear separable, we will use back propagation network. Okay. And the rule that we will use to train, that rule is called as gradient descent या delta rule we will call. Okay. This is a rule, training rule that we called. Okay. How we are going to train? For example, this is a linear combination of our weight that I have represented using vector form also. There are two ways. Okay. We will use to train that non-linear separable using this delta rule. Okay. Which will best fit our approximation to the target concept. How it will be done? Let us see. So this error is, find out, this is my estimated output and this is the output that was given by my network. The algorithm that I am using, my algorithm is providing this output, but my estimated output is TD. So we will estimate it and we will find the error. So what we are trying to do, we are just going to minimize the error between these two values. My output from the algorithm and my estimated output that I want the output. So what is the role of this training rule? This training rule will minimize the error between these two values. So for that we will use this training example. Okay? So now the question is that how we are going to train a training example which cannot be separable in a linear time. Okay? For that we will use multi-layer network which is learned by back propagation algorithm. Okay? So how we will do this? So for doing this, we will just create a network X. We will create a network, similar network. Input layer will be there, then hidden layer will be there. Input layer, hidden layer and output layer will be there. We will just make a network. And how we are going to train this network? Using this back propagation algorithm. Okay. Let us check how we will going to check this back propagation algorithm. This is the algorithm. This is the back propagation algorithm which will take input. Training example number 1. This is the learning rate, some total number of inputs and in, output and hidden. Because we know that in a multi-layer network we have 3 units. Number 1 is called as input unit, number 2 is called as the hidden unit, and number 3 is called as the output unit. Okay. So firstly what we will do, each training example is a pair of the form x and t. X is my instances, okay, t is the target. So we can represent it using the vector representation x, okay. Eta is a learning rate, and we will keep this learning rate value as small as possible. So for example, I have considered here as 0.05, okay. Ni is the number of network inputs, n hidden is the number of units in hidden layer, and out is the number of output units. Okay. So firstly what we will do, we just create a feed forward network. This is the step number 1, feed forward network with some input having some hidden unit having some output. Okay. So then at next what we will do, we will initialize all the network weights, okay, to some small random numbers. And what we will do, we just repeat these following steps. This is the number 1, first step, number 1 step, okay. This is the propagation network. See, this is my input layer. For example, for easy understanding, I am taking the input layer x1, x2, x3, okay. 2 units hidden layer at hidden layer and 2 units at output layer. For example, okay. This is my x1, this is my hidden unit, and this is my output unit. Okay. I am providing the input x1, x2, x3. Okay, students. Now, the input from this first unit goes to this hidden unit. I just name it x41. The weight I have assigned w41. Similarly, x51, xw51. Similarly, x42, w42, x52, w52, x43, w43, and x53 and w53. Okay. Similarly, from hidden unit, the output will be given to the as an input to the output unit. The naming conventions I have used here is x64, weight wx4. Similarly, x74, w74, okay, wx5, xx65, x75, and w75. The same process will be repeated here. Okay. And we will get a desired output O6 and O7. This is feed forward network. So this is the first step that we have completed in a back propagation algorithm. We just want to propagate this input from x1 to output. Okay. Now what happened? My algorithm will generate some output. Okay, that is my output O. There is some estimated output. There must be a difference between these two output. What is our role? We will try to minimize these estimated output and the output given by the algorithm using some training rule. Then what we will do? We will just propagate back this input from where we are getting the input. We just back propagate this output from where we are getting the input. This is how this back propagation algorithm works. Okay. So what I have illustrated, I just create a feed forward network, just show you where I have taken input. How many input I have taken? I is equal to 1, I is equal to 2, I is equal to 3. 3 input units. Okay. Hidden units is equal to 1, h is equal to 1, h is equal to 2. 2 hidden units will be taken, and output unit is equal to, we have taken 2 output units in our example. Just I have illustrated before. Okay. Then also I have initialized some weight. Okay. I have also initialized some weight. See, w41, w51, w42, w52, w43, w53. Similarly, hidden to output w64, w74, w65, w75. This is the weight. Okay. Now what I have to do now until the termination condition. What is the termination condition here? Termination condition is that until or unless I do not get the difference between my expected output and the output given by the algorithm, it should be minimum. Until or unless I just iterate the loop. ठीक है. What I will do, I will propagate the input forward through the network, number one. ठीक है. Now next, if the error comes, that there is a difference between my estimated output and the output provided by the algorithm, then what I will do, I will just calculate the error term using this. ठीक है. At hidden layer, I will calculate the error term using this, and then I will update the weights using this equation. Okay. This is the 4-step algorithm that is called as back propagation algorithm. ठीक है. Then okay, then what we will calculate our first step? While propagating, I just do the summation. See, I have done the summation here. ठीक है. That I have already discussed, doing the summation. After doing the summation, I have to use the activation function. What activation function I am using? Activation function means I have to calculate this delta, है ना, and I have used here a sigmoidal function to calculate the delta. After calculating this value, for example, this will be calculated as delta x or delta y, whatever notation I am using here. ठीक है. This is a sigmoidal function. So after calculating this linear combination of input and weight at unit number 4 and at unit number 5, ठीक है, we will use this value here and calculate this term 1 upon 1 plus e power minus x. This is activation function that we are going to use, sigmoidal function. See, this is the vector input. This is activation function that we are going to use here. Sigmoid function, sigmoid unit. Okay, this is the threshold function that we called it. I have assumed here it at x, e की power minus x. Okay, this e की power x. This is the calculated value of x. This will be inputted here. Okay, this is the sigmoid function. So after this sigmoid function, see, the same thing I have briefed you before. Sigmoid function in single layer perceptron model. Okay, this is a sigmoid function. Okay, that I have used here. Okay, students. Now what I have done here, similarly for this unit number 6 and unit number 7, I have done the linear combination here, because the output from the hidden unit will be calculated here. In the same fashion, I have used here also linear combination. Okay, again I have used this delta x will be used, this sigmoid function will be calculated here. Okay, then I will check whether I will get my estimated output or not. Okay, if I do not get this estimated error, if I do not get this estimated output from this algorithm, then what I will do, I will just feed back this output to calculate the error term. Okay, how it is calculated? Using this delta k. ठीक है. So how we will calculate this? This will be calculated. We will propagate the error backward through the network. For each network unit k, I will calculate the error term. How it will be calculated? This will be calculated like this. Delta 6 will be calculated, delta 7 will be calculated. Okay, how it is calculated? I will keep it here. Delta 6 O6 1 minus O6 T6 minus O6. ठीक है, delta 6 will be calculated. Similarly, we will calculate delta 7. Okay, then we will calculate delta 4 and delta 5. So this is the hidden layer. So for hidden layer, I will use this term. Okay, so hidden layer, delta h, delta 4, O4, 1 minus O4. I will do summation, and after doing summation for each output, how many output units we have? We have two output units, delta 6 and delta 7. For each output 6 and 7, we will calculate this term, summation W HK. HK means this delta H will be calculated here, delta K will be calculated here. Okay, so summation, this will be calculated W4 delta 4, W5 delta 5. Okay, students. So we will propagate the error backward. For propagation, for output unit, we will use step number 2. For calculating the error at hidden unit, we will use step number 3. ठीक है? Okay, students. So after this, we will update the weight WJI. ठीक है? We will update the weight WJI. How it will be updated? WJI will be updated when we will add this quantity here. And how this quantity will be calculated? This is calculated using this term. See, this is eta here. This is a learning rate. Gradient descent method is used here. Eta. Okay? And we will do the changes, and again the loop will be iterated. Again the loop will be iterated. Again we will calculate whether the error that we are getting is minimized or not. Until or unless that error will not minimize according to our limits, we will keep on iterating this same loop again and again. Okay? Until unless we do not reach this termination condition, we will just repeat the loop again and again. Okay, my dear students. So just you have to keep in mind here कि we have to firstly calculate this output 06 and 07. Okay? Firstly we will find is my this error is okay or not. Okay? Then we will back propagate it. How we will back propagate it? This output unit error will be calculated using this equation. Okay? Okay? And hidden unit error will be calculated using this equation. Okay? This hidden layer error will be due to the output. How many output units we have? Both delta 6 and delta 7. It will be calculated here, and after that we will update the weight. How it is updated? By learning this learning rate, eta, that we call it. Okay, students? So this is how this backpropagation algorithm works. Very easy. Very easy. Just you have to keep in mind, whenever we do not separate this input in a linear time, then we will use what type of neural network we will use? We will use, yes, we will use multi-layer feed-forward network. Okay? And this multi-layer feed-forward network is implemented, this algorithm that is called as backpropagation algorithm. Okay? Thank you, students. Thank you very much.